Sounds good.
Alrighty, welcome. Let's to our presentation on the nanotechnology and the future of submarines. It's presented by myself, Ben Shrimpton, and AJ Lewis.
Hello.
So, what is nanoscience and nanotechnology? Nanoscience is the study of particles and materials that typically range from about 1 nanometer all the way up to about 100 nanometers. And 1 nanometer is 1 billionth of a meter. Nanotechnology is the manipulation and application of these particles. With nanotechnology, scientists can alter the physical and chemical structure of a variety of materials to change their properties.
So, why is nanotechnology special? Oh, nanotechnology is special by manipulating the nanoscale structure of materials. The physical and chemical properties of material can be altered. These can include things like electrical conductivity, material strength, malleability, and much more. These things occur due to effects from a vastly increased amount of surface area compared to the volume they are held in. The surface area of a 1 centimeter cube made of 1 nanometer cubes is larger than a football field.
So, the present of nanotechnology in submarines is nanophotonic modeling. So, nanophotonic modeling is a process of using sensors which can detect nanoscale wavelengths, which are near and sub-infrared light. And that light is used to determine how things like sonar and LiDAR will bounce off the scale or the model when it's at full working scale. These models are about 100,000 times smaller than their real-life counterparts, so the wavelengths must be scaled down appropriately. These sensors will act similarly to an antenna, and the antenna will detect visible light instead of the radar or the LiDAR. And like I said, it's about 100,000 times smaller than typical detection methods. And when it's this small, you can set up a whole radar system on a surface the size of your desktop. And to the right, we can see a full scale model of an A-12 spy plane being tested for radar in the more normal sense.
Nanophonic modeling in submarines. By using nanophonic modeling, scale models of submarines can be made to be much smaller without losing any accuracy from the detection methods. This will greatly reduce the amount of time it will take to do tests. The models can now be 3D printed instead of being handcrafted. Testing times will be reduced due to smaller scale, and associated costs will drop due to significant and reduction in size and the ability to 3D print.
The future of nanotechnology in regards to submarines. We're going to start with medical nanomotors and micro submarines. Microscopic submarines make use of nanoscopic motors to deliver medicine to targeted spots. These nanomotors are able to generate thrust by having a bioactive enzyme, a catalase, which reacts with the internal environment of the patient. This enzyme will react with things like pH or the oxygen concentration of the blood or a variety of other factors to generate bubbles, which in turn generate thrust. So, when a pill is swallowed, millions of microsubmarines will kind of be inactive, and all of them contain a certain amount of the drug. Once the capsule reaches its target location, the microsubs will then be released, and they'll start navigating to the release site um, using the pH gradient or whichever gradient they're based off of. Once they reach the destination, the drug is then released. So this allows for targeted drug dosing, which can remove a lot of harmful side effects um, that a more traditional approach to drug ingestion might have. Something So, especially in the case of an anti-cancer drug, it won't affect healthy cells. It'll ideally just target the area around the unhealthy cells. So, another possibility is the use of SAMs, or self-assembled monolayers of mesopore supports. These are nanodevices that are able to efficiently purify water in an eco-friendly manner. They are created from nanolayers of a variety of materials, all on top of another nano ceramic baseplate. These layers have a porous structure that allow them to absorb various toxins in a targeted manner. By changing the material for each layer and the dimensions of that layer, different toxins can be absorbed. Things like it might be lead, it might be mercury, it might be nuclear radiation, or a whole slew of things. By introducing them into the water supply of military submarines, things like mercury, which are found in high quantities in the ocean, can be safely and efficiently removed from the water. Some submarines can be underwater for months at a time, and when they're down there for so long, it is necessary that the water supply is constantly being kept clean and fresh for everyone aboard. And to the right, we can just see kind of a rough diagram of what a SAM's disk or unit might look like with various nano layers of some mineral or material on it.
So fuel cells. When we think of most fuel cells, we think of what's in our cars. For us living on the coast, we think of cars, boats, uh, motorcycles, basically anything with an engine. But these fuel cells are not the most energy efficient. They can be wasteful and they can overburn or underburn different amounts of fuel, leading into a loss of energy and a bigger environmental impact. And so what scientists in the last 40 years using nanotechnology have found is that there are small hydrogen powered fuel cells, typically ranging between 1 to 100 nanometers. They haven't figured out how every single one works yet, but they're trying to use them um, uh, to be more energy efficient. And so what they use is they use ionized hydrogen in order to combine with oxygen, and the transfer of energy through this five plate system creates enough energy to fuel a car micro on a micro scale. And what it the output is any unused hydrogen can be reused later on in the uh, fuel cell's lifetime. But what happens is you get this clean product because H2O is just water. And so we can reuse that and break those molecules back down and reuse them in this, and it becomes a cleaner, safer method for alternative energy and fuel sources versus relying in fuel cells that are unstable, that they burn too much gasoline or diesel, and really aren't that healthy for the environment. Uh, One of the newer things that's happened since 1993 is that we have found out that there is something called EMI, electromagnetic interference. And these are commonly found in the automotive industry or any engine and that runs basically gives off these EMI particles. And it gives them off in two ways through radiation and conduction. And and these when in high amounts, can be so strong that they can affect humans' health or animals' health by changing the DNA structure, and they can cause long-term effects like cancer and other things. But what they also found is that these waves are what are commonly found in radar, and so Oh, the military uses them in the paint or special applicating coats that they put over their different vehicles, such as submarines, planes, and ground vehicles, to make them more less detectable. And so, when you have certain amounts of EMI ratings coming out of these different machines, they use those ratings to either absorb or deflect other electromagnetic interference devices to make it seem like an object's smaller than it is, or it's almost not there. Uh, they're, they over the past 10 years have taken leaps and bounds to the point where in 1997 they were able to first build a boat that was unseeable due to radar. Only downside with it is that because it's undetectable, it creates a void on a radar map. So that void is very, very detectable that there's no readings coming back. And so over the past 10 years, they have gone and improved upon these different EMI ratings and made it so that way uh, the radar cannot detect their vessels as easily, as well as making it so that way they seem like they are the ocean floor more than disappearing.